Okay, so a series of different questions, but well, no, just two different classes of questions here in part two. But let's go through it. The first one is really about bases, really, or indices, isn't it? So it says the jet paid £25, £25, £25 for materials in January X1, and it says this is the base month. Um, Now this base month is at 100, right? Because we don't have any other. Let me just have a look. I don't think. Let me just look carefully just to make sure I'm right. When I look through the question, I don't see any other. There are no. I just want to be sure there's nothing given in the question that I've missed. But that is the base month of 100. So when you see base month, it's at 100. Or, yeah, it is at 100. If you like, in general, it is at 100. When you hear the word base month, this 25 means this is the base month here of 100. Because what they then tell you is that you go further down the queue, the index is expected by December to have increased by 109. So basically, inflation or prices are expected to have increased. The general price index or increase is really should have gone from 100 to 109. I mean, technically, anything that goes from 100 and 100 to 9, you accept, right? In this simple, very simple, lovely simple case is 9%, right? Because you're saying here that the growth from here to here is 9, and we always do that on top of where we started, and that is 9%. So equally, I can nicely apply that and sort of argue, therefore, that I expect the price to be £25 times 1.09, 25 times 1.09, which is £27.25. So I'm expecting this to be £27, £27. 25 is what I'm expecting. Okay, right. This next question here, if you have it does well, I suppose you might not have done budgeting, but if you have gone through the course or you have been looked at some of the exam kit questions, which you need to be doing before you start doing this, um, is that you can see that really this is just the high-low method glorified. So let's play with that quickly. Um, so it says here that let's just draw the graph. It says here that when 150,000 units are manufactured, the energy costs are 55,000, right? So I'm just going to put that here, 55,000. And when 200,000, I'm going to check something before I do this, but just to sort of assume, I mean, I am almost sure this is a fixed, semi-variable cost. It says that they rise to 70,000. So I suppose if I wanted to be 100% sure this wasn't a purely variable cost, I mean, it tells me to use this. So I know this is semi-variable because with semi-variable, there's a fixed element, you see, and there's a variable element. So I know that, but you could test it. You could say, well, if it was purely variable, right, that 55,000 over 150,000 should be the same thing as 70,000 over 200,000 because if they're variable, they should be exactly the same, right? So 55,000 divided by 150,000 is 0.36, and 70,000 divided by 200,000 is 0.35. So they're not the same. So I mean, of course, you can see that this 3.5, some economies of scale, it could be argued as the reasoning for that. So I know it's not all variable. I know. I mean, I suspected it wasn't. It makes no sense to give you this equation if it was all purely variable. Now, we simply apply what we know about the high-low method. So we know that the change, what we're really looking for is to understand what happens when um, with the production of one extra unit, how much does the cost increase? And we can sort of do that, therefore, by comparing it across the spectrum and sort of arguing that, in effect, we ask ourselves, what is the change in cost? 70,000, 70,000. What is the change in cost over the change in units? And so we have we have this picture here, and this is 15,000, of course. 70,000 minus 55,000 is 15,000 divided, of course, by 100 and divided by 50,000. That's 50,000. 200,000 minus that is 50,000. So this, if you like, is the with every unit. That's the whole point. Every time we have a unit, how much does the variable cost increase by? And that's 15 over 50 in effect, or 15,000 over 50,000. 15 over 50. That's 3. 5, 3 over 10, and so 3 divided by 10, of course, is 0.3. So you have a 30p change in variability. So your B is 30p, 0.3. Yes, so B is 30p. Now the question then becomes, well, all I need to do is plug that in, right? I know that I'll just clean this up. I know that the total cost, I can pick this one here with 150,000 units. I know that the total cost for making 150,000 units is 55,000. So 55,000 is equal to this fixed cost plus 30p times the 150,000 units that I'm making. And 0.3 times 150,000 is equal to 45,000. So 55,000 is equal to fixed costs plus 45,000, and therefore fixed costs are equal to 55,000 minus 45,000, and therefore your fixed costs are equal to 10,000. Oops, sorry. And that's 10,000. Great stuff. So this is an example of a semi-variable cost. And you could have applied the same principle into the business here, and you would have said the same thing, that 70,000 was equal to fixed costs plus 0.3 times 200,000. This would have given you 60,000, and you would have found that your fixed cost was still exactly 10,000. So the point here is that everything's working along that line, that trend. Okay, great stuff.